He circled the ones, I guess, on the papers, didn't you? Are you just going to tell him?
Yeah.
All right, so he'll tell you as he goes through which ones he needs to do. And I need to tell you one other thing. Molly got through calculus.
Oh, good. Good. So she's done with her math? She probably doesn't take anything beyond calculus. I think only math majors go beyond calculus. So.
Yeah, she's business administration's major, so but she got through it, David. So, God bless. All right, go ahead.
Good for her. Let's see. You've got one circled here. You said you've already done it?
Yeah.
Okay, so let's go to 2. Oh, man. I'm having a little trouble reading this. It's just a little blurry. Let me blow it up a little bit. Given points A and B, find the coordinates of P on that line in the given ratio. Okay. I think what they mean, you tell me or not if this is what they mean, but I believe this is what they mean. If I label 3, 9, that's right there, 3, 9, that's point A. And if I label point B as 6, 15, we'll put it up there. Connect them. It says there is a point P on here that has a ratio of 1 to 2. In other words, I assume what they mean is that AP to PB is 1 to 2. Is that correct?
Well, how they explained it in class is it was breaking up into 3 equal parts. Or
that's what I've done. In other words, if I drew a third part there, then that distance from A to P is 1/3 of the distance from A to B. Okay?
Okay. You see the reasoning? Not because this is
partition.
The question I guess I have is, when they say the ratio is 1 to 2, do they mean A to P relative to P to B, or do they mean A to P relative to A to B? Probably, if they told you to break it up into 3, they mean A to P relative to P to B. Let me label this a little bit nicer here. This is P right there. This is A. Okay? So what are the coordinates of P if these are in a 1 to 2 ratio?
Well, what we did is we took the initial of x and y. In this case, it would be 3 and 9, and then we took added the partition, so it would be 1 over 3, and then we times that by the slope, by one part of the slope.
Okay. Okay. That's. I have another way. Let's talk about midpoint. If I was looking for the midpoint here, I would add the x coordinates and divide by 2, right?
Yeah.
I would add the y coordinates and divide by 2.
Yeah.
Well, in this case, I don't want the midpoint. I want the 1/3 point, right?
Yeah.
So if I take the coordinates, if the x coordinate is 3 here and the x coordinate is 6 there, what's the x coordinate of P going to be?
Would it be 6 plus 3 divided by 3?
Well, 6 plus 3 divided by 3 is 3. So that gives you the same x coordinate as A, which can't be right. This would be 4, 5, 6, right? So the x coordinate of P has to be 4. Now let me see if I can figure out how we can algebraically come up with that. If I take 6 minus 3, and that's the distance the x coordinates go between A and B is 6 minus 3. And I know I have to divide that line up into 3 parts, right? One more than that number. So if I'm dividing it up into 3 parts, I'm going to divide that by 3, and I get 1. But what that means is it's this x-coordinate plus 1 to get the x-coordinate of P. With me?
Yeah.
Now let's do the same thing to get the y-coordinate. Let's subtract the 2 y-coordinates, divide by 3. That's going to be the y differential of each of those 1/3 segments, right?
Okay.
So what's the y-coordinate of P?
Would it be 5?
It would be 9 plus 2. In other words, when I did 15 minus 9, that's the length from here to here in the y direction, okay? So I'm dividing that by 3 to give the y dimension between any of these 1/3 segments. Well, if P is 2 bigger than A, then it's got to be 11.
Yes.
Now, if I want to check my work, I'm going to take the distance from A to P and make sure that it is in a 1:2 ratio with the distance from P to B. Well, the x-coordinate from A to P is a differential of 1. The x-coordinate from P to B is a differential of 2. There's my 1:2 ratio. Y-coordinate from A to P is a difference of 2. The y-coordinate from P to B is a difference of 4. There's my 1:2 ratio again. So I'm doing it properly. So that answers A. Now, if I want a ratio of 1 to 4, how do I have to divide up that line into how many parts?
5.
Correct, always one more. So if this is minus 5 comma 10, and this is 15 comma minus 5, I know I don't have them graphed properly, but that's really neither here nor there, right? In other words, it doesn't matter if I have A in the right spot. A is actually somewhere over here, but I don't care. I know I have to divide this thing up into 5 equal pieces. 1, 2, 3, 4, 5. Okay? So if P is right there, this point here, what is the x differential between each of these 5, in other words, between A and P? What is the x differential going to be? What's the x differential between A and B? Take B and subtract A. 15 minus a minus 5. That's equal to 20. I'm going to divide it up into 5 equal parts.
That'd be negative 4.
It's positive 4. To go from A to P, the x has to increase by 4. So what is my x-coordinate on P going to be?
Would it be 9?
I'm adding 4 units to minus 5.
Oh, I see that. So it would be negative 1.
Correct. Okay. Now, to get from 10 to minus 5, I'm taking minus 5 minus 10. That's minus 15. I'm going to divide that up into 5 parts. this case, my differential in the y is -3 between each point. So don't pay attention to my graph. It's not correct, but doesn't keep us from calculating the y. I have to go -3 every time I go from this point to 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 that point. I got to subtract 3 from each y. So what's the y coordinate of P?
Would that be 8?
It's 10 minus 3.
Oh, do you go by the initial
Yeah,
-5?
you start here, and we know we have to go down 3 every time we move to another point.
So it'd be 7.
It'd be 7. And I probably confused the issue a little bit by drawing the picture the way I drew it. Let me draw the graph the way it should be drawn. There's point A. That's -5, 10. And point B is way over here. In other words, point B is way down here at 15, -5. So really, I'm progressing from A to B in that direction, and there's P right there. Okay, so I can tell my x coordinate has to increase at every step, and my y coordinate has to decrease from step to step. So if you're looking at a proper picture, it's a little easier to realize that the y coordinate, I have to go down 3. We can see it. I have to go down 3 between each of these fifth breakups. Okay? So we figured out the formula. The formula is you take y sub 2 minus y sub 1, divide it into one more than that quantity, and that is the step size between each interval.
David, could you start over with the sentence? The formula is a phone call came in the middle of your sentence on my iPhone, so we missed it.
Yeah, in other words,
just write it out for me.
If you don't want to draw a picture like I did here, in other words, if you want to just do this whole thing algebraically, then it's the step size. I can't think of anything else to refer to it as. The step size, the x step size is x sub 2 minus x sub 1 divided by the number of steps. In this case, there were 5. The y step size is y sub 2 minus y sub 1 divided by the number of steps. Again, 5. Does that clarify it? It might be a little different than the way he taught you in class, merely because I haven't seen a problem like this, even though I have 8 other geometry students. This is a bit of an unusual problem, where they want you to segment that line up into parts. Usually it's just finding the midpoint. So this is a little different. And they may have you solve it based on slope, I don't know. This works if you understand it.
Yeah, this one's easier than the way they taught us.
Okay. Just remember what step size means. Step size means going from A to P, that's the step size. That step size is 1/5 going from A to B. And you get that by doing that.
Okay.
But David, before, when he does the formula, because he has to do x of 2 minus x of 1 over step size, that's where he starts.
Right.
It's easy to determine from looking at the problem what x of 2 is and x of 1 is.
Yeah.
But right, it's given. But then again, how does he determine the step size? Do you know?
Yeah, the step size is the ratio.
Okay, so
It's one more than that bottom number of the ratio.
Yeah, it's one. It's the top ratio number plus the bottom ratio.
Right. There you go. That's the way. Yeah, the step size is the sum of these two numbers.
Gotcha. And he just explained it well, so I think he's clarified it in his own mind.
I agree. I think he understands it perfect. Okay, number 3. Write the equation of the line parallel to this that goes through that point.
I've always had a problem with writing equations from a point.
Well, start with slope rather than the point. What's the slope of the line parallel to that line?
Would it be y equals negative 2x?
No, it's the same as this slope. In other words, if you have two lines that are parallel, they have the same slope. No matter what it is. They're parallel, same slope. So the slope of the line that we're going to write the equation of is 2. Right? Because that's the slope of this line. This is not the equation of our line. This is the equation of another line. And they're saying we have a line that is parallel to this line, but it goes through this point. Now, how you solve this all comes down to what you know better. There's two formats for the equation of a line. There are slope-intercept and there's point-slope. Do you know both of them? Which one are you most familiar with?
Probably slope-intercept.
Let's use it then. I'm convinced that if you use the one you're most familiar with, you're going to be better off. Okay? We need to solve for m and b before we have a proper equation. In other words, my final equation is going to look something like this. Okay? Still going to have x and y in it. That's important to understand. Well, we know what m is. That's 2. So I can fill that in. You don't know what b is. How can I solve for b? I know it goes through this point.
Well, you could just go down to over 1 until
Hold on. There's an easier way to do it. And it's very important you understand this. If it goes through this point, then I've got to be able to plug that in for x and that in for y and satisfy the equation.
All right.
That's going to let me solve for b. So plug in my point into that partial equation. What do you get?
You get 3 equals 2 times negative 1 plus b.
Now we can solve for b. What's b equal to? Hold on a second. My computer. Uh-oh. Not good. My mouse continues to work on that thing, but my tablet, it does not. Hold on.
Okay.
Just a second. I gotta get my cursor working. There we go. All right. So, we had a slope of 2. We had a point of -1, 3. And we solved for b. What was b equal to? We had 3 equal to 2 times minus 1 plus b. Solve that for b.
Would maybe 5.
So now what is our equation of the line that they are looking for?
Y equals 2x plus 5.
There you go. That's the easiest way to do it. There is another way, but let's just always do it this way. If you always do it this way, you can't go wrong.
And so, David, is that the basic formula then? Well, it is for this one. So,
well,
but
there's 2 basic formulas. There's the slope-intercept formula.
It's the one he's going to use. So, and that's the y.
There is another one called point slope.
All right, we'll skip the point slope, but
it's just as valid. It's going to give you the same answer, but like I said, you can use either one. Let's use this one because he's most familiar with it.
Right, and that's what. And what I'm trying to get is the formula for the slope-intercept is y equals mx plus b.
He knows that one, I guarantee you.
Okay, so you got that one. All right.
That's the first one everybody is taught, and that's the one everybody pretty much knows.
So that's the slope.
Not actually the easiest way to do it. The easiest way to do it is point slope, but it's a little more confusing, and then you also have to remember the point slope format. So this is what I tend to teach people who just want to memorize slope-intercept format. Okay, we good to go? Notice that our equation's not the same one as what we were starting with. We started with 2x plus, what is that number, 7?
7.
Yes.
Yeah. And the equation we ended up with was y equal 2x plus 5. Different equation, but right next to that line. This line goes through the y-intercept of 7. This one has a y-intercept of 5. Okay. Now, question number 4 is very, very similar. Find the slope of the line perpendicular to the line that passes between those 2 points. Well, what do we know about perpendicular slopes? What are they?
Are they always negative?
Negative reciprocal of the slope of the line that it's perpendicular to. In other words, if I have a line here, and I have a slope of 2, m equals 2, and I draw a line perpendicular to that line, then I know the slope of this line. What's the slope of this line?
Negative 2.
Minus 1/2. You have to do 2 things, not one thing. You have to do 2 things. You have to flip it and change the sign. Always remember you have to do 2 things. Okay, so in this problem, they want merely the slope of the line perpendicular to this line that goes through these 2 points. So let's figure out the slope of this line. And then we'll take the negative reciprocal of it and we'll have the answer. We don't need to come up with an equation of the line. We just need, this is strictly about slopes. So what's the slope of that line?
Is it 3 over 4?
It's negative 3 over 4.
Because you got to flip it and make the sign. So,
You can't go, here's the thing. This is a very common mistake people make. The slope is rise over run, right? That's where you start. Well, what's rise? Rise is y sub 2 minus y sub 1. Run is x sub 2 minus x sub 1. Now, it happens that it's also okay to do y sub 1 minus y sub 2 as long as you do the same thing in the bottom. You see what I've done?
Yes.
What's not okay is to mix it up. In other words, you can't do this and then do x sub 2 minus x sub 1. You'll get the wrong sign on your slope. So either of these is okay, and it's perfectly acceptable to use this one when it's convenient to do so. But with these 2 points, it's really no more convenient to use this one than it is to use this one. You're going to end up with a negative number regardless. So let's use the official definition. And let's just be very, very specific with our numbers so that we don't lose the sign. What's y sub 2?
4. I mean 3.
No, that's x sub 2.
Oh, I thought you were asking what the outcome was. Y sub 2 is
6 minus 9. Okay? What's x sub 2?
3.
What's the bottom look like?
3 minus a negative 1.
What's the top?
That would be 3.
Negative 3. Right? 6 minus 9 is minus 3. What's the bottom?
Would that be 4?
Positive 4. So my slope is negative 3/4. That's the slope of the line between those 2 points. So what is the slope of the line perpendicular to that line?
Would it be 4 over 3?
Got to do 2 things. Got to flip the number and change the sign. So 4/3 is the answer. Now, let's go back a moment. I want to clarify what I was talking about. Let's say my 2 points are those 2 points. Now notice that I could do 6 minus 9 divided by 3 minus 5. That's a lot of negatives. So if I was looking to do the slope here, I'm going to do y sub 1 minus y sub 2 in top and bottom. I'm going to change this to 1 and 2 also. Why? Because it allows me to work with nothing but positives. Y sub 1 minus y sub 2 is a plus 3. X sub 1 minus x sub 2 is a plus 2. There's your slope. So when your points are such that you can deal in all positives, sometimes it makes sense to go 1 minus 2 as opposed to 2 minus 1. If I were to do 2 minus 1, I would have minus 3 over minus 2, which still turns into 3/2. You get the same slope regardless. So it's okay to go either way. What is not okay is to mix it up like you did the first time. In other words, you went 9 minus 6 on top, but then you went 3 minus a minus 1, so you really did x sub 2 minus x sub 1 on bottom. That's what you can't do. If you're going to go 1 minus 2, you got to go 1 minus 2 on the bottom also. You understand what I'm saying?
Yep.
Okay. Let's see. I'm sorry. I forgot. We are only going to 7 for now. I have a 7 to 8 I gotta go to.
Yes.
I'll be back in touch with you at 8.
Thank you, David.
Okay, Patrick. David. Bye-bye. It'll be a different meeting ID number. I'll text it or send it to you. Yeah, I'll text it to you, right?
Right. You can just text it to me and we'll be here.
Okay. Bye-bye.